This is Principles of Ecosystem Ecology, Chapter 4, Water and Energy Balance. In this chapter, we will explore the integrated cycles of energy and water. In fact, energy and water are so tightly integrated, they need to be examined concurrently. Now, the authors state that the hydrologic cycle, the cycle of water, driven by solar energy, is the master cycle that drives all other biogeochemical cycles. They also note that water and solar energy are essential for life, and that water and energy cycles are so tightly intertwined that they cannot be separated or treated separately. Now that's pretty strong evidence, or at least statements, to think about both energy and water together. And one of the main ideas that we'll cover here is the patterns of evapotranspiration. And evapotranspiration is really two processes that are lumped together. First, we have evaporation and then transpiration, where evaporation is movement of water from the land surface or water body into the atmosphere and going from a liquid form into a vapor form. And transpiration is simply evaporation that happens through plants. So it's the same process where you have liquid water in plants that then goes into the atmosphere, into vapor form. But because it goes through plants, we call it transpiration. And evapotranspiration is one of the key processes in the water cycle. Now, the reason that water and energy cycles are so tightly linked is that evapotranspiration, that movement of liquid water into the atmosphere as vapor, accounts for 80% of the turbulent energy transfer from Earth to the atmosphere. So what that means is that most of the light or solar energy that comes down goes actually into evaporating water. And only a relatively small fraction goes into directly heating the land and the air. And so since most of that energy goes into evapotranspiration, we really need to take a look at the two together. Now, the water cycle itself, that hydrologic cycle, can be represented relatively simply. Where you start is a matter of opinion, but if we start with the water that's on the land surface, either in lakes or rivers or larger bodies of water like oceans, that the first thing we have is evaporation. And that's, again, water that goes from a liquid into a vapor state, and that goes from oceans, lakes, and streams directly into the atmosphere. At the same time, we also have transpiration, which is the same process, but it happens through plants, and that also delivers water into the atmosphere. When it's in the vapor state, eventually it's going to condense back into the liquid state, and if it condenses in this manner, we'll get clouds, and then those clouds are going to generate precipitation, which is the movement of water from the atmosphere in a liquid state down to, or a solid state, down to either the ground surface or water bodies. And then from there we'll have movement such as surface runoff or movement through groundwater, and then the cycle begins again. So that's a relatively simple representation of the water cycle. And there are other representations that are still incredibly simplified, but you can see it gets a lot more complex. So we still have evaporation, for example, arrows going up, evaporation here from different sources of water. Transpiration is in here too. And then there's different pathways by which water is going to move, and it's going to move through the atmosphere too. So we can draw a lot more boxes and a lot more arrows if we wanted to, but those general processes of evapotranspiration or evaporation, as well as condensation and precipitation, are the same key factors to think about for the water cycle. Now, one thing when we're thinking about both energy and water cycles, that normally in ecosystem ecology, it's typical to think about pools, fluxes, and pools. And we said that in general, when we represent individual processes, we start with the source pool of flux and then the end pool. With water and energy, it's a little bit different. And that usually will describe processes based on the fluxes and then the pool that it enters and the flux in. So if we think about sunlight, for example, we don't represent how large the pool of energy is in the sun, but we tend to start with the flux of energy from the sun to a pool and then the flux of energy out of it. And the ratios are often a lot different too than what we might be used to. The amount of stored energy, for example, in an ecosystem tends to be relatively small compared to the fluxes, depending on the time scale that you're looking at. And so often these, for energy too, these pools are going to be relatively small such that we don't even think about them. And instead we just characterize the pools or the fluxes in and the fluxes out. And with that, there'll be transformation of energy into different types of fluxes out of there that we're going to talk about also. So when we start to think about water and energy, the way that we describe it might be a little bit different than what we set out in an ideal or a typical situation, but we're still going to work through the same basic properties and processes as far as pools and fluxes are concerned.